to finish up this unit are a few extra methods of integration. So if you try everything else and nothing works, these are a few other tools in your toolbox. My sort of pep talk about this, or like reading the fine print, is these, what we're going to cover today, are not likely to be super heavy topics on the AP exam. You might see one, okay? So don't super stress out about it, but I'm still going to teach it to you. Just because it's not like as likely to come up as something else doesn't mean that we're not going to cover it and I threw like 2 of them on your test, okay? Okay, yeah, so it will be assessed. You have to know it, okay? So I wrote these on here. I debated doing that or making you write them because I feel like if you write something, you'll remember it better. But then I was nice and I printed them for you. Okay. So look at these. I need you to just look at them. Okay. You don't need to worry about memorizing the left side of the equal sign because that's going to be in the problem handed to you. That part's going to be printed on the paper. So you really don't need to worry about that. And if you look at the right side of the equal sign, do you see how they are all basically the same? Look, arc sine u over a plus c, arc tangent u over a plus c, arc secant u over a plus c. Do you see how they're all essentially the same format? Okay, here's the only differences. Arc sine does not have what in front of it? Okay, so that one doesn't have a 1 over a, and arc secant has an absolute. That's it. Okay. Beyond that, you just need to be able to identify which one is which, and there's only 3 that are fair game. Okay, I don't know why they picked these 3, but that's what it is. Okay, so looking at the left sides of the equal sign, what do you notice about the one that's for arc tangent that makes it different from the other 2? If there's no square root, it's arc tangent. Do you need to know whatever the rest of this gobbledygook is? Not really. Just no square root means it's arc tangent. Now, out of the 2 that have a square root, what's the difference between those? Yeah, do you see how this one has like an extra little doodad out front of it? Okay, that's the one that'll be arc secant. You don't really need to memorize the rest of it because you just need to go, oh, that's tangent, oh, that's sine, oh, that's secant, arc, whatever. Okay, let's give it a shot. We're going to decide what A is, and we're going to decide what U is. A is a number, U is a variable. U takes the place of X, just like your U substitution. For this one, A is going to be 4. How did I get 4 from 16? And look at, yeah, do you see how these all have squares in them? So I square rooted it. They're usually going to be perfect squares, okay? U is going to just be X. This square, yeah, like we're getting rid of the square, okay? Now, just like with your U substitution, we're going to do du. What is the derivative of just plain X? Yeah, 1 dx. You can put the 1 if you want to. I probably wouldn't, okay? Now, when you go to substitute in, and you may end up skipping this step moving forward, because again, all you have to do is be able to identify, is this one arc sine, tangent, or secant? Sine. Do you see how there's a square root, but there's not like a little extra? If it's multiple choice, I would want you to look at this, go, oh, it's arc sine, and then pick the answer. There's probably only one A, B, C, D choice that would say arc sine. Do you get what I'm saying? You just have to be able to go, oh, it's that one. All right. So, but to be thorough and show you the whole everything, in place of dx, we're going to put du. And then down here, it'll be square root of a squared minus u squared. And you can see that that's the part that means arc sine. But again, moving forward, if you don't want to write that, honestly, I'm quite lazy. I usually don't. I usually skip that step and just go, oh, it's going to be arc sine. So my answer is arc sine, or sometimes you can see it written sine with the little -1, you know, the little -1 thing, how that means the same thing, inverse. I know it's Friday, but okay, cool. Arc sine u over a, so it'll be x over 4 and then plus c. And that's the answer. Okay, it's never as bad as we think it is, right? Looking at this one, is it going to be arc sine, tangent, or secant? Just, okay, and on the AP exam, you will probably be able to pick the correct answer just knowing that. Okay, so you just have to be able to identify. So A is going to be a number, U is going to be a variable. In this one, A is 3. How did I get 3? Square root of 9. Perfect. Does anyone want to give U a stab here? Like 4x. Perfect. And then you're going to do du just like you did with your U substitutions. The exact same thing. What's your derivative of? So 4 dx, and we're going to adjust it with a 1/4. So you're going to end up with a 1/4 in front of it. equals dx, yes. All right, so out front, I'm gonna skip this step if that's okay with everybody. We already know it's gonna be arcsecant, okay? I'm gonna put that 1/4 out front, and we are basically just gonna write the answer. Now, arctangent and arcsecant have that 1/a out front, so it's gonna be 1/3. My a is 3. You know what, I'm gonna run out of room. I just realized, let me scooch down here. You're gonna make it, bless you. So arcsecant, u/a plus c. All of them are u/a plus c. So what is u/a for what we have on our little list here? Yep, 4x, and that is the one that does have the absolute value in it. But that's your answer. Now in multiple choice, instead of 1/4 times 1/3, they're gonna write 1/12. Okay, but like that's the answer. Let's move on. All right, just gonna try one more. This one will be arctangent. We know that already. Deciding a and u. Now 7 is not a perfect square, so it's going to look funny, but what is a going to be? Well, u is going to be 5x. It's going to just be square root of 7, like whatever that is. We're just going to leave it square root of 7. So du is going to be 5dx, and perfect. You see, you guys are saying it before I can even write it down now. I'm a pretty fast writer, though. I can write pretty quick. And then you kind of just write the answer. 1/5 goes out front. Arctangent does have that 1/a, so it's going to be 1 square root, you know, whatever that is. We're going to just leave it alone. And then it's arctangent u/a plus c. They're all u/a plus c. So it would be 5x over square root of 7 plus c. And like, that's just the answer. Like, that's all you have to do. So basically being able to identify them is really all you need to do. Again, it's not a super likely topic to come up, but I'm not going to skip topics. We're going to cover everything because that's how I feel about it, is we're going to teach everything. All right. Next method we're going to look at is completing the square. I know Algebra 2 was a journey for you guys. So we're going to real quick review how to complete the square. I'm not even going to put it in an integral. We're just going to do an Algebra 2. Welcome back to Algebra 2. Okay. What you're going to do is copy the first 2 terms. Oh, sorry. Thank you. You're going to copy the first 2 terms. And then you're going to put plus. And what you do is you take the middle number, you divide it by 2. So 6 divided by 2 would be 3. And then you square it. So 3 squared is 9. And then the way I teach it is give it a hug. You want to give it a hug. Now, here's the thing. You're not allowed to just go around changing the problem. Wouldn't that be nice? You could just be like, yeah, I don't like this problem. I'm going to change this and make it something else. It still has to be 10. Oh, well, hold on. How do I turn a 9 back into a 10? I would need to add 1. Okay, 9 plus 1 is 10. And then the point is, this is the whole point of the whole thing, is you want to write it as something squared. If you were to factor that, it would split into x plus 3 times x plus 3. So I always call it a twin. I've never heard it called an evil twin, but I call it a twin as well. Twin. X plus 3, x plus 3. So I'm going to write it as x plus 3 squared.
So the evil twin, because how I learned it was you have the 9 and then you have the minus 9 on the side.
So if you have an equal sign and you're solving it, I teach it that way, but we're not going to actually solve, we're going to integrate them. So I agree with that. But I do call it a twin as well. All right, so here we go. Let's give this a shot. Now we're going to do it with some calculus sprinkled on top because we have an integral. I'm going to put that dx off to the side. That's totally a personal preference. I know, I'm sorry. A little scattered today. You can put the dx in the numerator. That is 100% personal preference. Neither of us is right. Neither of us is wrong. We're allowed to be different. All right. So I'm going to copy down the first 2 terms, x squared plus 6x. This one's actually the exact same as the example I just did. We're going to add 9 and give it a hug. Now, you're not allowed to just go around changing the problem, unfortunately. You have to turn a 9 back into a 25. So what would you have to add? And oh my gosh, isn't that a perfect square? That's so cool. Yay. So we're going to write it as 1 over what? Yeah, x plus 3 squared plus 16. And now we are back to the arc whatever things that we literally just did. It's the exact same. What would A be? A is going to be a number. Good, perfect. U is going to be x plus 3. The derivative of x plus 3 is 1 dx, or just, good. You guys are so quick. You pick up what I say so quickly. All right, is it going to be arc sine, tangent, or secant? If there's not a square root, it's tangent. So anyone want to give it a stab? What's going to come out front? Yeah, quarter, 1/4, arc tangent, x plus 3 over 4 plus c. That is the answer. Plus c. Does Delta Math take it if it's a lowercase c?
Yeah.
It'll take it?
Yeah.
Okay.
Sometimes.
Sometimes. Depends on if it's being polite here. All right. I don't want to have to keep rewriting the square root every single time, so I'm going to kind of do a margin problem with this one. This is going to be a little tricky because of the negative sign. Negatives are the most commonly missed symbol always up through calculus and beyond, okay? I'm going to take that negative and factor it out. So instead of negative x squared, I'm going to have positive x squared. And instead of plus 4x, I'm going to have minus 4x. Okay, and then we're going to pause right there. Because the example we just did happened to be the same as this one. I should probably go back and fix that so they're not the same. You have to divide by 2 and square. So, and this one's a little weird. 4 divided by 2 is 2, and then 2 squared is 4. Okay, but look, we're going to pause again. We're going to do this slowly because there's a negative. It's not actually a 4. It is a, okay, good. You came with me on that. -4. I have to turn a -4 back into a +5. I have to keep it what it was. So go ahead. Yeah, but see how there's a negative that we factored out? It's actually a -4. And then you square it. You have to square it to get 4. It's weird because 2 plus 2 is 4 and 2 squared is 4. So this one's a little weird. All right, we have to turn a -4 back into a +5. So what would we need to add? Oh my gosh, 9's a perfect square. Ain't they crazy? Okay, so now I'm going to put it back in the integral. I just didn't want to have to draw the whole problem all over again. Again, I was being lazy. So 1 over, I'm really sorry I'm interrupting what you're doing there. Big old square root. Now I'm going to put the 9 first, and you'll see why. It's going to be 9 minus something squared. And a lot of times I'll just draw it out blank and then go back, like leave a blank and then go back and fix it. This will split into, if you factor it, x minus 2 times x minus 2. So it's just x minus 2 squared. Are you getting that this is mostly algebra 2? This is like mostly an algebra 2 problem. We haven't even really done calculus. All right. Now we're back to that arc stuff that we just did. What is A going to be? 3. Perfect. U is going to be beautiful. Oh, hold on. Oh, okay. A is always a number. U is always a variable. And then du is going to, again, just be dx. So we don't need an adjustment. Is it arc sine, tangent, or secant? Again, you just have to identify. Now, sine does not have that little 1 over a out front. So just skip that, and we're going to just write the answer. It's arc sine of what? X minus 2 over 3 plus c. Cool, you guys handled it. Nice. This is going good. This is perfect. The timing is going to be good and everything. Today is a good day. You're going to be all right. Don't I have a sign that says that? Oh, my keep calm and follow the unit circle fell down. I'll need to put that back up. All right. Last method also involves something from, oh, this isn't actually algebra 2. This is pre-calc. I know that was weird for you guys. So actually, let me pause for a second and see if you even learned this. Did you learn synthetic division or long division of polynomial? I'm seeing heads nodding. Okay, well, I'm going to fix it. It's okay. I'm going to fix it. Okay. What number would make this 0? 1. So what you're going to do off to the side, it's like a margin problem. You're going to put 1 in a little box. Do you remember that? Sort of. I'm going to keep going. Okay. Now what you're going to do is steal or thieve all the coefficients from the problem. So what's really in front of the x cubed? 1, and then -3, and then 5, and then -3. Now, they have to go in descending order, and if something's missing, you would put like a 0 as a placeholder, but I think most of these, oh no, you know what, I do have one where something's missing, so I'll show that to you. Nothing was missing in this case. It went x cubed, x squared, x, and then x to the nothing. Maybe just watch me do this first, because this is one of those things where if you look away, you're going to miss it. Now, when I teach this in pre-calc, I always bring this up because this is hilarious to me. People try to start the problem, and I'm like, what are you doing? There's nothing there. Do you see how there are no numbers down here? I'm like, what are you even multiplying by? The first thing you have to do is bring down the first number, all right? You're going to multiply, add, multiply, add, multiply, add, multiply, add until you get to the end. Ready? Just watch, and then I'll let you copy it down. 1 times 1. 1. Add the column. Don't look away. If you look away, you are going to miss it. It is that fast. Do you see how I got -2? Now we're going to do it again. 1 times -2. Add the column. 3. 1 times 3. 3. Add the column. I made the remainder come out to 0 for this one so we could do like an easy problem to start with. The remainder won't always be 0, but you multiply, add, multiply, add, multiply, add until you get to the end. Now we're going to put it back in the integral. We did a side problem with some pre-calc. Now we're going to go back and put it in the integral. Oops. You're going to start with your power 1 less. And the reason why is we divided. So instead of starting with x to the 3rd, we're going to start with x squared. Good. And these are your new coefficients. So it's going to be 1x squared minus 2x plus 3 dx. And now it's a problem we can actually do. So what is your antiderivative for x squared? Yep, good. Or I like 1/3 x cubed. Again, neither of us is wrong. It's just a personal preference. I like a coefficient, right? Minus, this would be just x squared, and then plus 3x, and then plus c. Wow. We're going to try it again. If you're like, hey, I didn't quite get it, we're going to try it again. All right, off to the side. What number would make this denominator 0? All right, -3 goes in the little box. We're going to steal all our coefficients. Now we're going to need a 0 placeholder in this one. I made something be missing. Do you see how it's 2x cubed? And then we have 4x squared. But then what's missing? Yeah, you have 0 x to the 1st and then -5. Please don't try and start the problem with nothing there. I'm like, what are you doing? There's nothing there. You have to bring down the first number. So bring down the 2. And again, if you want to just watch and then copy it down after, I'll pause and give you a second. You're going to multiply, add, multiply, add, multiply, add. So -3 times 2, -6. If you add the column, perfect. All right, do it again. It's cyclic. You're just going to do it again. -3 times -2, +6. Add the column 6. All right. -3 times 6. -18, add the column -23. This one has a remainder. It's not any harder. There's going to be one extra step. Okay, but it's really not any different. Now we're going to take that and put it back in the problem. So we're going to put it back inside of the integral. So it's going to be 2x squared minus 2x plus 6. Now watch how we do the remainder. We're going to put minus 23 over the x plus 3. What we're saying is that is left over. We were unable to divide that one out, so it just stays over the x plus 3. It's not any harder. It's just like one step of more writing. You just leave it that way, okay? And now finally you get to do the calculus. Antiderivative for this first term. 2/3 x cubed, beautiful, minus x squared, good, plus 6x. Now pause. Pretend the 23 is not there and pretend the plus 3 is not there. What's your antiderivative of 1 over x? ln. We're just going to put that stuff back in. So it's going to be minus 23 ln x plus 3 and then plus c. So again, there's a little bit more writing, but it's not any more difficult. You just kind of tack on the remainder with an ln. You guys do that. All right, this one will have a remainder too. So if you were like, hey, wasn't so sure about that remainder, we're going to do one more. All right. What number goes in the little box off to the side? 4. Perfect. Oh, good eyes. We're not going to put plus C. Instead, we're going to put such that and get a numeric answer. What does the numeric answer represent? Area. Derivative means slope. Integral means area. I marked you absent because you're in the wrong seat. Remind me to fix my attendance. And then I marked him present. Remind me to fix my attendance after I finish this. I didn't look and I just realized that right now. Okay, 4 goes off to the side. No, that's okay. A lot of people moved. I just didn't catch that. Okay, just remind me to fix it. All right, so our coefficients, we have 4 and then what? Negative 21 and 23. Let's have everybody do the multiply, add, and we'll just make sure we got the same thing. I got this, what did you get kind of thing, all right? Yeah, well, neither did I. Like, everybody just take a minute and do that, and we'll just all make sure. Basically, if we all get the same remainder, then we probably all did it the same, because if you end up with the same number at the end, then you probably did it right. I did. That's what I got.
See how I love myself the way those arrows are going.
Did you draw arrows for?
I just drew so I visualized.
Okay, cool. Yeah, your notes belong to you. I'm not going to take them back from you. You write whatever you need to write. All right, we're going to put that back in the integral and keep your boundaries because we need those. So what's going to go back in here? Now, this one was just an x squared. So when we put our numbers back or our variables back in, we're going to start with just x. Good. So it'll be 4x minus 5 plus 3 over the x minus 4. What we're saying is we were unable to divide that part out. It remains. It is a remainder. And then you do your antiderivative. So this first term will be 2x squared, good, minus 5x plus the 3 and the minus 4 are kind of just there, all right? It's going to be 3 ln x minus 4. Don't put plus c. Instead, you're going to put such that 0 to 2. But the other way around. We're going to, well, hold on. We're going to do upper minus lower. Set it up blank. Just set it up blank. It's so much easier if you set it up blank. We're going to plug in 2 first. 2 squared. 4 times 2, 8 minus 10, good, plus 3 ln of, oh, okay, 2 minus 4 would be negative 2, but the absolute value of negative 2 is 2. Okay, cool. And then if we plug in 0, that'll be 0 minus 0 plus 3 ln of 4. Perfect. So whatever that is. But it's a numeric answer and it represents an area. Okay, I'm going to say one more thing that ends up on the recording. This is the end of the unit. I recorded like over a week ago, or about a week ago, the review video. It is up there and I gave you your review.
Nice.